All right, Sclemon, I'm going to go ahead and review this circle information with you. Before I do that, I want you to take a couple of notes on all the different ways that you could see the relationship between an arc, the measure of an arc, in comparison to the measure of an angle. There are basically four different types. The first one is what we call a central angle. And a central angle is when the center is on the circle and it has a relationship with the arc itself. So if in a central angle, if the angle measurement is 30 degrees, then the arc is also 30 degrees. So the measure of the arc is equal to the measure of the angle. That's in a central angle. If you have a situation where you have the angle is in the interior of the circle, but it's not on the center, this is called an interior angle. And the relationship here is you actually have two arcs that go with the corresponding angle. So let's just say this arc is 40, this arc is 60. The measure of the angle is equal to half the sum of the two arcs. So in this case, this would be a 50-degree angle because it's half of 40 plus 60. All right, the next type of angle is when the vertex is actually on the circle. And this is what your quiz is mostly focused on. And the idea here is that when it's on the circle, it's referred to as an inscribed angle. And if the arc is, let's say, 80 degrees, the angle is half that arc. So in this case, the measure of the angle is equal to half the arc. And then finally, the last type of angle that you're going to run into is when you have a situation where the vertex of the angle is actually outside the circle. In this case, just like the interior angle, an exterior angle has a relationship between two arcs. So if this is angle 2, here the measure of the angle is equal to half the difference. This is opposed to half the sum like the other ones. This is half the difference of the two arcs. So if this arc was 40 and this arc was 10, then our angle measurement would be 15 because that would be 1/2 40 minus 10. So those are your relationships. So going back to your quiz here, the first thing they're telling you is that angle BAC is 56 degrees. So since this is on the circle, the relationship between this angle and this arc is that the angle is equal to half the arc. That means this arc here has to be 112. Now, the question that you're actually being asked is, the question that you're being asked is what is the measure of angle BDC? Angle BDC is right here, and it actually shares the same arc. So again, that angle is equal to half that arc, which happens to be 112 degrees. So half of that would be 56. So your answer here would be 56. Now in this particular problem, they're asking you to identify what is the missing theorem that you would use. So you want to know, how did you get from step 1 to step 2? Here we have the measure of arc KL is equal to 2 times the measure of the angle. So that's that inscribed angle that we were talking about. So they're actually proving it by going through all of these steps here. So you have the measure of angle MJL, which is equal to MLJ. They share the same value since you have an isosceles triangle. these base angles would be the same. That's also equal to 2 times one of those angles. So I can actually use what's referred to as the substitution property here to come up with this conclusion, which proves for us that the measure of any inscribed angle is half the measure of its arc. On this next problem here, you have circle V. You have several pieces of information. You're given WXZ is 30 degrees. You're also told that line segment WV, XV, ZV, and YV are all radii of the circle. Well, if they're all radii, that means that all of their values are congruent. So that's our given information. The question that we're being asked is, what is the measure of arc WUX? And here is WUX, which is this angle here. So what you can do is you can look at the idea that this is an isosceles triangle. Each of these angles is 30 degrees. Since the triangle has to add up to 180 degrees, if I took 180 minus 60, that would mean that this angle here is 120. Since this angle is a central angle, vertex is on the center, the arc is equal to the same measure as the central angle. So my answer is 120. So in a central angle, the measure of the angle is equal to the measure of the arc. Okay, on our next problem here, they're using some algebraic representations of lengths. So our angle KJL is equal to 7x plus 8, that's this angle here, and angle KML is equal to 3x plus 8. Notice that both angles share the same arc, which is KL. So, since the angles both share the same arc, that means that the angles are actually equal to each other. So we want to set those two angles equal to each other and solve algebraically for that value. So I get 4x equals 16, so x is equal to 4. In order to find the measure of the arc, I must first find the measure of the angle, and I'm going to do that by placing this 4 back into one of these equations. 3 times 4 is 12, plus 8 is 20, which means that each of these angles have a value of 20 degrees. Now, since the relationship here, the vertex is on the circle, the measure of the angle is equal to half the measure of the arc. So that 20 degrees is half the measure of whatever this arc is. Therefore, my arc has to be 40 degrees. All right, here what they're trying to do is they're telling you that since ln is a diameter, you have an inscribed angle, we want to prove the fact that LMN is actually 90 degrees. So what we're going to do here is start off with the fact that you have the diameter and you have an inscribed angle. You know that LKN is therefore a semicircle. And since the whole circle is 360 degrees, that means that this angle here measures 180 degrees. Since this arc measures 180 degrees, therefore the inscribed angle would have to equal 90 degrees, and that is because the vertex of this angle is on the circle. Again, that goes to your inscribed angle, and the measure of the angle is equal to half the measure of the arc. So since it's half the measure of the arc, the reason here would be inscribed angle theorem. All right, here we are. We have a tangent to the circle at point A. And the question here is, if you are told that CAE, so CAE is this angle right here, is 95 degrees, it would like to know what is the measure of arc CBA. Again, the vertex of this angle is on the circle. The vertex of this angle is 90 degrees. So the measure of the angle is 90 degrees. So the vertex of this angle is 90 degrees. So the vertex of this angle is 90 degrees. So the vertex of this angle is 90 degrees. So the vertex of this angle is 90 degrees. So the vertex of this angle is 90 degrees. So the vertex of this angle is 90 degrees. So the vertex of this angle is 90 degrees. So the vertex of this angle is 90 degrees. So the vertex of this angle is 90 degrees. So the vertex of this angle is 90 degrees. So the vertex of this angle is 90 degrees. So the vertex of this angle is 90 degrees. So the vertex of this angle is 90 degrees. So the vertex of this angle is 90 degrees. So the vertex of this angle is 90 degrees. So the vertex of this angle is 90 degrees. So the vertex of this angle is 90 degrees. So the vertex of this angle is 90 degrees. So the vertex of this angle is 90 And so we have the measure of the angle is equal to half the measure of the arc. So since the angle is 95 degrees, you want to know 95 is half of what arc measurement? So if we multiply both sides by 2, we get 190 degrees is equal to the actual measurement of that arc. Here we go again with some algebraic representations of our angle measurements. Here they're telling me that this angle, ADC, which is the central angle, is equal to 7x plus 2. It also tells me that the arc AC is equal to 8x minus 8. Now, since this is a central angle, we go back to the idea that the measure of the angle is equal to the measure of the arc because it's a central angle. So I can set 7x plus 2 equal to 8x minus 8. When I solve for x, I end up with the fact that x is equal to 10. Now the question is, what is the measure of angle ABC? So B is actually on the circle.